Here's our video for Unit 7, Day 7. This will be the last video for this unit. We're going to talk about today, we've been talking a lot about functions, different parent functions, how we tell if something is a function. We're going to talk about combinations of functions today. So four basic combinations for functions we'll talk about first are just the sum, difference, product, and quotient of functions. So sum, just like with numbers, sum of functions means we're adding functions together. So our notation for that f and g are functions, we have f plus g of x. Alright, our algebraic rule, pretty simple. We just add the two function values at that input value together. So f of x plus g of x. Same idea for the difference. That's our notation, f minus g of x, and we're subtracting the function values. So product is the same as well. fg of x indicates the product of two functions, and we multiply their values at that. We multiply their output values at that input value. And quotient, same idea, except we're dividing. Only difference with the quotient is we obviously, since we have quotient, we have a fraction, we can't have g of x equal to 0, so we can't divide by 0. So I'll go through an example using these two functions, f and g. I'll go through an example just evaluating each one of these, sum, difference, product, and quotient of these two functions at the value 3. So basically we'll just use our rules from the previous page. So if we're starting with the first one, f plus g at 3, that's just going to be the sum of the two functions evaluated at 3. Right, so I would plug 3 into my f function, which would be x squared minus 3. So it would be 3 squared minus 3. Plug 3 into my g function, which is 4x plus 5, so it would be 4 times 3 plus 5. And we're just simplifying, doing the arithmetic. 9 minus 3 plus 12 plus 5. So f of 3 is 6. G of 3 is 17. So f plus g of 3 is 23. Same idea for the difference. F minus g of 3 will be f of 3 minus g of 3. We already evaluated those right here, so that's going to be 6 minus 17. Which will give us negative 11 for our difference. Next one we'll do is the product. So we're going to be multiplying again. We already have our values for f of 3 and g of 3. Now we're just going to be multiplying f of 3 times g of 3. That's going to be 6 times 17. And that gives us 102. And then the last one is quotient. So again, following the same rule, we're going to be dividing f of 3 by g of 3. We have those again from that first problem. So that's just going to be 6 over 17. So that's just an example of how we evaluate different combinations of functions, sum, difference, product, and quotient when we're given a value. On the next slide, what we're going to do is actually evaluate the rule. So write a new rule for a function given two functions, combining them and writing a new rule. So the idea is still pretty much the same, except now we're just working with the general form of the function and not actually evaluating it at a particular input. So first one is our sum. We're going to be adding the two functions, so I'm going to be adding f of x to g of x. Right, so I'll add my function rule for f of x, x minus 5, to my function rule for g of x, x squared minus 1. We can combine all our like terms, and we get, as our function rule, x squared plus x minus 6. Same idea for the second one, except now we're subtracting the two function rules. So we're going to take f of x, subtract g of x. So that will be x minus 5 subtract x squared minus 1. The important thing here is don't forget to distribute this negative sign. So x minus 5 minus x squared plus 1. And again, we combine our like terms. In our function rule, we have negative x squared plus x minus 4. For our product, work down here. Same idea as before, we're going to be multiplying the two function rules. So that's going to be f of x, x minus 5, times g of x, x squared minus 1. Again, be careful, make sure we're working with polynomials the correct way, foiling this out, multiplying everything on the left by everything on the right. So x times x squared gives us x to the third, negative x, negative 5x squared, and positive 5. And then we'll just write this in our standard form, descending order. Have x to the third minus 5, x squared minus x plus 5. And our last one is quotient. So we have f of x over g of x. That's going to be our f rule, which is x minus 5, over the g rule, which is x squared minus 1. And there's nothing we can simplify there, so we can just leave it written out like that. So when you combine the functions, that will change, depending on what combination of function it is, will change the domain for the two functions. So here I have a linear function for f, which has all real numbers as its domain. Here you have a quadratic function that has all real numbers as its domain. Right, combining them in different ways can actually change that domain. So for the first one, we still have a quadratic, so our domain for the first one will still be all real numbers. Same for the second one is a quadratic, the difference. So that will also have a domain of all real numbers. Third one is cubic, so again we have domain, all real numbers. But our quotient is now a rational function, so anywhere this denominator is 0 is not going to be in the domain. So solving that will give us two values to exclude from the domain, and that's positive and negative 1. Both of those would make the denominator 0, so they're not in the domain. So this domain changes. We have negative infinity up to negative 1, not including negative 1, negative 1 to positive 1, not including either one of those, and then 1 to infinity. Right, or just another way of saying x is not positive or negative 1. So there's one more combination of functions we'll go over. It's called a composition of functions. So a composition of functions is when we actually take a function and plug it into as the input of another function. So the notation we have for it looks like this. And the way we say that is f composite g. Right, what that means is basically we take the g of x function and we plug it into the f function, or evaluate f at the output for g. So one special property of composite functions, which we talked about when we talked about inverses, if f and g are inverses, then we compose them with each other, we'll just get back x. So f composite g of x equals x. That's a special property for inverse functions. Basically means if they're inverse functions, they cancel each other out, and we just get back what we put in. So using these two functions here, we'll do an example. We'll find f composite g at 2. So what this means, I'm going to find f at g of 2. So the first thing I have to do, just like our order of operations, is we have to do parentheses first. I have to find out what g of 2 is. So g of 2, I'd plug into the g function, would be 2 squared plus 6, which gives me 10. So then we take this output, and that's what we're going to plug back into the f function. Right now, look at my f function is 3x minus 4, so it's going to be 3 times 10 minus 4. So that's going to be 26. So basically we're just evaluating one function first, plugging the output into the other function. So the one thing that's important to point out is that the order that we write these in matters. We can create two different functions based off the order. So f composite g of x is going to be different unless they're inverses than g composite f of x. Right, and here we're going to evaluate the entire rule, just like we did for the sum and difference and product and quotient of functions. We're going to evaluate the general rule. So we're going to find the function f composite g of x and the function g composite f of x. So the way we find it is the same as we did before. We're going to take, for the first one, the g function, we're going to plug it into the f function. In this case, our g function is x squared plus 6. That's going to become the input for our f function. So we're going to take our f function, everywhere there's an x, we're going to replace it with x squared plus 6. simplify, and we get for our function rule f composite g at x, 3x squared plus 14. For g composite f is going to be a little different because now we're taking the f function and we're plugging that into the g function. This would be g at f of x. So the input for our g function is going to be the f function itself, 3x minus 4. So everywhere in our g function there's an x, we'll replace that with 3x minus 4. Remember, when we square a binomial, we have squared outside of the parentheses. We have to FOIL that. We have to multiply that whole thing out. So 3x minus 4, 3x minus 4, and the plus 6 at the end is still there. So I multiply this out. 3x times 3x, 9x squared. 3x times negative 4 is negative 12x. 3x times another negative 4 is another negative 12x. That gives us negative 24. X is total, and then negative 4 times negative 4 gives us positive 16, and then the plus 6 at the end. And we simplify, and that gives us our rule for g composite f at x. We have 9x squared minus 24x plus 22. So that's it for this video. Important thing to take away is understanding how we combine functions, making sure we're careful when we evaluate functions, how we plug in and then evaluate a function. If I look for any other resources about this material, look for combinations of functions. And for these last two slides, look for compositions of functions.